Alright, so yesterday we learned about a special type of triangles. What type of triangles were those, Trent?
Right triangles?
Yes, they were right triangles, but they were even more special than just being right. What were their angles, Trent?
45, 45, 90.
Yeah, perfect. 45, 45, 90 triangles. They were right and they were isosceles at the same time. Isosceles triangles. We learned that there was a pattern. And because there was a pattern, we get to take shortcuts. DJ, what was the pattern? Perfect. X, x, x root 2. Now, there was a problem when our hypotenuse didn't have a root 2. Normally, we would want to do like 5, 5, 5 root 2. But when our hypotenuse didn't have a root 2, when we were going backwards to find a leg, what did your notes tell you to do? Say it louder, Jose. Divide. So instead of multiplying by root 2, which is what we do when we go forward, we're going backwards, so we would divide by root 2. So Anahi, what do you get in your calculator when you do 40 divided by root 2? We're trying to pull a root 2 out of it. 28.2. So that is what x is. On both of those, remember you can check your answer. 28, 28, 28 root 2. Plug that in your calculator and see if that equals about 40. Bless you. 28 root 2. Is it kind of close to 40? 39.5. I'd say that's pretty close to 40. So that does fit the pattern. It does work. Okay. Next one, Zaya, what do you get for y? 7.1?
Yeah.
What do you think, class? Oh, whoa, whoa, whoa. Can our leg be bigger than our hypotenuse?
Oh, no.
No. So we're going to do the same thing we did to solve for x.
Wait, I put 5 root 2, right?
5 divided by root 2, because you're going backwards, just like we are. See how this is the hypotenuse? I'm giving you the toughest ones for the warm-up. Yesterday, they were all easy. These were the toughest ones.
3.5.
3.5, you had it all ready to go. 5 divided by root 2. So when you're going backwards, you do need to divide. All right, look at yesterday's worksheet. So once we went over the warm-up and once we went over the worksheet, we've kind of already reviewed what we learned yesterday. But yesterday we came up with a pattern, and we got to use that for any triangle that was, what does this box mean? Right and isosceles. So if it was right and it was isosceles, we got to use our new trick. 3 root 2. Uh-oh. Something root 2. What did we have to do here? Divide. So both of these would be 8 divided by root 2. 8 divided by root 2. Today, we're going to learn about another triangle that also has a pattern. So there's 2 triangles out there that have patterns. The reason that we like these patterns is that we get to avoid using Pythagorean theorem. On every other triangle in the world, right triangle in the world, we have to use Pythagorean theorem. But on these 2 special ones, we get to use our pattern. Okay? So that's why this is called special right triangles. They're just a right triangle like any right triangle, except they show up a lot and they have a pattern. The other right triangles don't have patterns. Okay, if I gave you a triangle, I told you one angle was 90,
60.
one angle was 30. What would the missing one be?
60.
60. Very good. So today's lesson is called 30, 60, 90. Is that already in your notes somewhere? Yep, it's the title. 30, 60, 90. So yesterday was 45, 45, 90. Today is 30, 60, 90. What is going to be the pattern today? Remember how yesterday it was circle, 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 star. Well, today it's not quite as, it doesn't really fall into a chant like yesterday. Circle, 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 star. Not quite. So we've got circle, we've got circle, star, and then we've got circle, circle. What do you think circle, circle means? Times 2. Sounds great. What do you think the star represents? What did it represent yesterday? What? No? A square root 2. The star was a radical. And then the circle was a whole number. So today it's going to be a whole number, then a whole number times a radical, and then that whole number doubled. Let's see if we can find out. And we were going to do Pythagorean theorem with each of these, but we're going to save that, and I'm just going to reveal the answer. So I want you to stare at these and find out what you think the rule is. We're going to fill in the rule box in a minute. What do you think the pattern is? What's the rule? Yesterday the rule was x root 2. You need to figure out what the rule is today.
You don't?
Yep.
X squared, x root 3.
Not x squared, not 3 squared.
Cube.
3 squared is not 6. 4 squared is not 8.
X root 3.
There you go. Okay. So this is x. Notice this is 2x, right? 2 times 3. And this is x, whatever x is, times root 3.
This is
X.
complicated, sorry.
No, but it's not as complicated as having to do Pythagorean theorem. I promise. All right, go ahead and fill it in. This is your rule. X root 3, 2x. And then you need to fill it in on the picture as well.
No.
You're at the very bottom where it says rule. In the box where it says rule. X comma x root 3 comma 2x. And then fill it in on your picture. And we need to talk about which side is across from which angle, because that's really important. Okay, which side, Chris, in this triangle, which side would be the shortest side? Which one?
X.
Good. So the shortest side is always going to be across from the 30. The x, quote unquote x, the whole number, is going to be across from 30 every time. The medium side is going to be across from 60. That's always going to be the x times root 3. And then the largest side of your triangle is going to be your shortest side, just doubled. So your hypotenuse is always your shortest side, but just doubled. We can double things. We can all double things in this class. Okay. Go ahead and try one.
No.
Use your pattern.
Sorry.
Flip your paper over. Kind of waste of space on the other side so you can grab your warm shit today. X root 3, 2x. That's the pattern. X root 3, 2x. Yes, you have to fill this in because, like yesterday, I didn't want you to work ahead. X root 3, 2x. Oh, 22, yes. Okay, sorry. I thought it was 2 squared for some reason.
Where is that?
So this is x. So your x is 11. X root 3. Now, there's multiple ways to approach this. This one's a very basic one. When they give you the smallest side, the side across from 30, it's pretty much the easiest that you can get. Some of you are going to like to put the rule on your picture. Some of you are going to like to do the rule to the side because sometimes when you put it on your picture, it gets too messy. I'm going to show you both ways, and you use whichever way works for you. Okay? If you put it on your picture, across from 30, you'd put x. Across from 60, you'd put x root 3. And across from 90, you would put 2x. Then you would figure out what x is. In this example, Alondra, what is x? 11. So then you just follow the rules. X is 11. This one says x root 3. So what would we write? 11 root 3. We've now found a, without really doing any math at all. And then this one says double x. 2 times x. 2 times 11. 22. We've now found all sides of a triangle, and we didn't have to do Pythagorean theorem. 11 root 3, 22. Let me show you the other way. People who don't like to do it on the triangle because it gets too messy and they get confused. Some people like to go off to the side and write the rule in a little chart. X root 3, 2x. And just make a little chart. And then you see what you're given. Ooh, I'm given the one across from 30. That's the first one. So I'm given this one. And then they just, oh, why did I put 30? Sorry, 11. Yeah, it's not bad. So they're given that, and then you just follow the chart. Oh, x root 3. Oh, 11 root 3. Oh, double x, double 11, 22. The only thing is if you use the chart, then you have to go back and find out where they go on the picture. You would never use both. You would use one or the other. I'll keep teaching you, okay? I'll keep showing you how to do it. Try this next one. Add those numbers to your picture and see if you can find the missing sides using x root 3, 2x.
JK.
You always start with what you're given. What am I given? Was I given x? Was I given 2x? You always start with what you're given.
Oh, that's easy.
Yeah, it really is. Okay, Trent, what side length are we given? Say 24.
Oh,
24. And Trent, what is 24 across from?
The 90.
The 90. Very good. That's where you start. What am I given and what is it across from? So Trent, in this 30, 60, 90, where would I put it? Which column? The 30, the 60, or the 90?
Oh, 2x.
Yep, in the 90 column, 30, 60, 90. Good. Well, if 24 is double x,
12.
then, Jacob, what is x? Your card was actually up. Then x is 12. Because the opposite of doubling is halving. Just half it. And then the chart says, take x and attach a root 3. Well, x is 12. It's going to be 12 root 3. So there's our pattern. 12, 12 root 3, 24. Now we just have to make sure we put them in the right spot. Claire, what would 12 go across from? Across from the 30. Very good. So the shortest side is going to be 12, and the medium side is going to be 12 root 3. So J is 12 and K is 12 root 3. I know y'all got that one. Let's try another one.
Bring it.
Now bring it. Is that what you
Heck is
said?
that?
Label your picture. Make it look like mine.
Oh, never mind.
When I'm making this chart to the side, I realize that a lot of you don't need a chart at all. I'm just trying to give skills to people who, when they stare at this, don't know where to start.
I need the chart.
So if you don't know where to start, you always just write the chart down to the side. Thanks for being honest, Trent. Or sarcastic, I didn't know you were. Lillian, what are we given and what is it across from?
We're giving 6,
We're given
2,
2 root 3 and what's it across from?
this,
The 60. Very good. So if I'm in my chart, I'm going to put it in the one that goes across from 60. This is 30, 60, 90. So my 2 root 3, oh thank goodness, my 2 root 3 actually goes in the root 3 column. Because if it didn't, we'd have more work. Okay, Renard, what would x be? If x root 3 is 2 root 3, what's x? 2. And what's 2x?
4.
4. Ding, ding, ding. Just put the longest one on the hypotenuse and you're good. T is 4 because it's across from 90. And S is 2. Not too bad. 2. 2 root 3, 4.
So why is there a 4 for T?
Because you double it.
2x. So the chart says if x is 2,
Yeah.
then what's double x? What's 2x? Well, 2 times 2 is 4. Okay. So you just follow, you just obey the chart. Okay, this one's a tiny bit tougher. A tiny bit tougher.
Oh, yeah.
Excuse me.
Go ahead and fill out your picture. Make it match mine.
What the heck is this?
Betty, make yours match mine. This one's a little bit different.
This makes no sense.
Yes, it does. Stop complaining.
Oh, I get it.
No complaining rule.
I got it.
Complaining is not welcome here.
Wait, no, I don't.
Yeah, it's a little different.
Done.
Let's just wait to see.
Oh, wait.
Elijah, what do we have and what is it across from?
Oh, wait.
He's like, I don't want this.
I know it.
No, this is the easiest question. The first question of my questioning is the easiest one. Elijah, which side do we have and what is it across from? We have root 3. And what's it across from? What angle is it across from? 30. So we are given the one across from 30. Martin, where do I put this in my chart? Root 3 is across from 30. In my chart, where would I put it? In the X. Be careful. Remember, this is 30, 60, 90. So in my chart, I put it here, even though it doesn't look like it goes there, because it's across from 30. Are you watching this? I see frowns. It's okay. It's across from 30, so root 3 is x. Okay, DJ, if root 3 is x, then what's x root 3? X is root 3. So it's root 3, root 3. Does anyone know what root 3 times root 3 is? It's root 9. What's the square root of 9, class? 3. Cool. So that turned out pretty. Square root 3 times square root 3 is 3. What? No. Now the chart says take x and double it. Betty, what is x doubled? Betty.
Sorry.
Jose C, what is x doubled? This is x. Double it.
You got this, bro.
Jared, what is x doubled?
X doubled, that'd be 6.
Haley, what is x doubled? Okay, we don't need a calculator. Anahi, what's x doubled?
Is 3.
Zaya, what's x doubled?
I got
Araceli, what's x doubled? What? Madison, what's x doubled?
Say 6 again.
2
6.
2 root 3. Yep, you're right.
That's 5 even.
2 times square root of 3 is 2 root 3. It's 2 times root 3. 2 root 3.
That was it.
So this is 30. This is across from 60. This is across from 90. All right. So what is F? What's F? 3. Because look, it's in the 60 column. F is 3. What's E?
90.
2 root 3.
Well, it's diagonal to that triangle.
And that was a challenging problem. Not most of the ones you encounter will not be that one. So don't put your hands up in the air and say, I can't do this. Because most of them will not look like that. This one's going to be even more challenging.
No, I want to do it.
We have to do it. We have to do it. We have to push ourselves. If everything in this class was just easy and you got it right away, then you wouldn't get any better.
Oh, man.
You wouldn't be pushing yourself. You wouldn't be growing as a learner. Good attitude, Jacob.
Yeah.
X root 3 to x. Anahi, what do we have and what is it across from? We have 12 and what is it across from? What angle? 60. Okay, this is bad news. We have 12 and it's across from 60. So in our chart, we need to put 12 in the 60 column. That's bad news because it doesn't have a root 3. Wow. What did we do on the warm-up today when our hypotenuse didn't have a root 2 and we needed it to? We divided to extract a root 2 out of it. So to get from here to here, we're going to do the opposite of multiplying by root 3. We're going to divide by root 3. That's how you get from here to here. Divide by root 3. I'm going to let you go to your calculator on this one. I'm not going to make you do it by hand. So go to your calculator and do 12 divided by root 3. 6.92? So 6.9? All right. Araceli, if x is 6.9, then what is 2x? $13.9. What?
I don't even know.
Yeah, wouldn't it be 0.8? 9 times 2 is 18. 13.9 doubled. Yeah. Hey guys, to get from this column, to get from 30 to 90, all you do is double it. You just double it. Double means times 2. 6.9 times 2. All right, so what's A? 6.9. What's B? 13.8. And the agony is over. Okay, let's try this one. This one's the last problem of the day. What is it asking for? The perimeter. Dun, dun, dun. If the altitude is 4 root 3. Can everyone draw the altitude of that triangle, please, right now on your paper? Draw the altitude, if you remember what that is. I would start it right here if I were you, just to make it easy on us. Draw the altitude, start it at that dot. Go straight down, 90-degree angle. If the altitude, put a box, because altitude means it hits the opposite side at 90. The altitude is 4 root 3, then find the perimeter. Jared, if I have an equilateral triangle, what are his angles? Well, let's start with this. All of his angles are equal. All of his angles are equal. How many degrees are in a triangle? 180. What if I want all of these to be equal and I have 180 degrees to deal with? Divide by 3. Yeah. Do you know what it is?
60,
Yeah. The angles of an equilateral triangle are always 60. Now, wait a minute. Up here, we took the 60-degree angle and we cut it in half.
30.
Ooh. Guys, look. A 30, 60, 90 triangle.
Skill.
Yeah. What do we have and what is it across from? Because you need to be so used to asking yourself that. What do we have and what is it across from? We have 4 root 3. What is it across from?
60.
Thank the Lord that the one across from 60 has a root 3. That's great news. I'm not going to make the chart this time. So x is 4 and 2x would be 8. 4 root 3, 8. What is the perimeter of this triangle, Zaya?
I think I know, but I want
One of its sides is 8. It has 3 sides.
Okay, wait, let me tell you what I did. Tell me
Yeah.
if I did it right.
Okay.
I did 8 plus 4 plus 4 root 3.
Oh, yeah, that would be the perimeter of this little bitty triangle. I want the perimeter of the equilateral triangle. Every side is 8, Zaya. 8,
Oh,
8, 8.
so these many 4.
Yeah. Final answer. Lesson over.